Hi, my name is Jake. I'm an engineer on the AVKit team, and welcome to creating a great video playback experience. In iOS and iPadOS 16, we built a completely new media player from the ground up, bringing a whole new look and feel, designed to keep the focus on the content and fit within a broader spectrum of apps. We've also built in many novel interaction models that make using this new media player feel even more intuitive and seamless. And we think you're going to love it. In this session, we'll take a deep dive into the new system media player. We'll learn how to design amazing playback experiences. We'll see some exciting new visual intelligence features coming to macOS and iOS. I'll introduce an all-new interstitials experience coming with the new media player, and go over some new APIs we're bringing over from tvOS. And lastly, we'll go over a new feature in AVKit, selectable playback speeds. For tvOS 15, we redesigned the system player, bringing a whole new look and feel, as well as a host of new features and usability improvements to the system player. Well, we heard your requests. I'm happy to say we've revamped the iOS system player as well. We've completely redesigned the native media player, adopting the look and feel of the tvOS player, but reimagined for a touch-first device. We've removed the Chrome across the board, allowing the interface to feel native within a broader spectrum of apps, and bringing a more modern feel to the player. Let's dig deeper into some of the changes we've made. First, we brought the play, pause, and skip controls front and center to make them even easier to interact with. We've also adjusted the skip interval from 15 seconds down to 10, making it easier to track how far you've jumped with consecutive skips. Next, we've made some significant improvements to the usability of the timeline as well. We're removing the slider knob, marking the timeline's current position. Instead, the timeline can now be interacted with from anywhere along the slider. Drags no longer need to begin at the current time marker. This makes it even easier to find exactly where you want to go. We've also replaced the video aspect control with a more intuitive pinch to zoom gesture, which I'll show in a moment. And of course, the new UI looks great for portrait content as well. On iPadOS, the player integrates seamlessly into the system, with full support for keyboards, trackpads, mice, game controllers, and much more. We've also added a number of new ways to interact with the controls that make navigating the content and some common user interactions even easier and more intuitive. Let's take a look at these. First, we've added a new way to change the video's fill aspect. You can now use a pinch gesture to move through the available zoom levels. Pinching in will bring the video within the safe area of the display. Pinching out will zoom the video to fully fill the display. Next, we streamlined one of the most common interactions, play pause. You can now tap the center of the display, even while the controls are hidden, to play and pause the video. And lastly, we've added a new way to navigate through the media timeline. You can now scroll through the timeline from anywhere over the video, using the same interactions we all know and love in scroll views. As you begin to scroll through the video frames, the interface drops away, leaving only the most relevant UI, allowing the focus to stay on the content. We've also brought over some new features from the tvOS player. AV Player View Controller now supports displaying a content title, subtitle, and description natively from within the full screen UI. You can provide strings for each of these by passing AV metadata items to an existing AVKit API. Let's see how this is done. By default, the title, subtitle, and content description will be pulled from the media's metadata. However, the values in the media can be overridden if needed through the external metadata API on AV Player Item. A title can be added by creating an AV metadata item with the identifier common identifier title, and adding it to the player item's external metadata property. Titles should be short and descriptive to avoid cluttering the UI. Similarly here, we've added a subtitle by creating an AV metadata item with the identifier iTunes metadata track subtitle. The subtitle will be displayed above the content title and should be a few words describing the content. Lastly, a description can be added with the identifier common identifier description. This will display a chevron to the right of the title and subtitle. Selecting the title will display the info panel containing the content description. The description should be a few sentences with more info about the content. Tapping anywhere will dismiss the info panel. So to wrap up, we've revamped the iOS system player with an all-new look and feel, with new streamlined, touch-first interaction models, as well as a host of other improvements. Using AV Player View Controller in your app, you'll have the full support of the system player, support for picture-in-picture, SharePlay, visual analysis, native Catalyst support, new hardware and new feature support, and much, much more. And of course, all of this you get with just a few lines of code. Now, let's talk about how you can design amazing playback experiences in your apps. When we set out to redesign the system media player, we took a step back from what we'd built in the past and what we'd built for other platforms, and we asked ourselves, what makes for a good user experience? We wanted to share this process with you, how we've gone about designing the new players, why we designed them the way that we did, and what we think defines an amazing media experience. We think there are 3 things that make a media experience great. The experience should be intuitive. It should feel easy, familiar, natural, even if you've never used it. It should be tightly integrated, both within your app and with the system. And lastly, it should be content forward. At the end of the day, people are there to experience the media, and your apps and designs should reflect that. Now let's dig deeper into these 3, starting with making your experience intuitive. Oftentimes, when an app feels intuitive, it can be hard to put your finger on why. You just know it when you see it. So what actually makes an interface or an experience feel intuitive? And how can you design for it? We think it starts with familiarity. When you can draw on your past experiences to help understand something new, that's intuitive. When you don't need an explanation of how it works, or even need to think about how it works, it just works exactly as you expect. Every one of us builds experiences daily, interacting with technology and the real world. Both of these are great sources of experiential familiarity, and is often where we started when designing the new system media players. There are many types of experiences to draw intuition from, but I want to focus on 2. The 2 that we most often relied on when designing the system media players: platform paradigms and the real world. The first comes from our experiences using technology every day. Years of using TV remotes tells you that the arrow keys move focus left and right. Similarly, tapping a volume button on a touch-first device will mute the audio. These interactions feel intuitive because they're familiar. You can use these types of familiar interactions in your media experiences to help make your apps feel more intuitive, engaging, and even natural to use. Conversely, finding unfamiliar or unexpected interactions can be confusing and sometimes even frustrating. Let's look at some examples where we drew on this type of platform familiarity in the system players. A great example of this is the presentation and dismissal model of the iOS system player. The player animates its presentation in from the bottom, giving a subtle hint that the player can be dismissed by pushing it back down. We see this model used extensively across our touch-first devices. For example, the Now Playing UI in Music presents from the mini bar at the bottom and can be dismissed with an interactive swipe downwards. In some cases, though, we may draw on experiences not from our understanding of technology, but from everyday life. These types of experiences come from the real world. Millions of years of evolution have helped us develop a deep instinctual understanding of natural processes. You can tap into this understanding to help build familiar and intuitive experiences in your software. A great example of this is our new scrolling gesture in the iOS player. Similar to rolling a toy car across the table, each swipe over the video has momentum, continuing the movement of the timeline past the direct interaction until the timeline slowly comes to a stop. The momentum here alone builds an association with real-world moving objects. This association helps you discover the subtle depths of the interaction. Just like the toy car, I can make it go faster by pushing it harder, or pushing it several times in a row. And if I grab it, it stops. It feels natural because it is natural. And the best part about this is, if you use the system players, your app will feel intuitive. All of the natural interactions we built, an inherent intuition and familiarity people have with the system player. All of the design paradigms, optimized in a way that tvOS, iOS, and macOS users will understand natively. All of this you get with just a few lines of code. Building an intuitive design is one aspect of making your media experience great. But without all the features and integration points people expect, your app can inadvertently pull focus away from the content. This leads us to the second crucial aspect of an amazing media experience: tight integration. When an experience is tightly integrated, all of the functionality, features, and devices people expect to work just work. And importantly, they work in a way that's consistent with their expectations. As people use their devices, they become accustomed to relying on the features of the platform. For example, pulling down the control center and seeing your content populated in the Now Playing media controls. Or responding to a notification while watching a TV show and having the video continue smoothly into picture-in-picture. Building this tight system integration into your app is key to making your experience feel seamless. Your app should feel like a native part of the system, and we work hard to provide you with the tools needed to make that possible. This includes things like Core Spotlight integration to make your content searchable, Now Playing info so your content can appear in the system media UIs, media remote commands, allowing your app to respond to things like the play button being pressed on a keyboard or TV remote. We even provide the ability to integrate your media directly into the TV app, delivering your content to an even wider audience. In addition to making your apps feel native, it's important to provide all the features that people love. Features like AirPlay, SharePlay, and Picture-in-Picture. We think people will expect these features, and providing them enhances the experience in using your app. People will use your app across many devices, and even more input formats. Providing support for all of these is crucial in ensuring your experience is accessible to everyone. This is particularly important on tvOS, where supporting all available remotes is critical to ensuring everyone can use your app. This is one reason we always recommend using the system media player on tvOS. Your app should ensure a fluid experience with all TV remotes, keyboards, trackpads, game controllers, and headphone controls. Additionally, you should ensure your app's UI elements are drawn within the screen's safe area to avoid collision with rounded corners or notches in the display. We recognize building support for all of these integration points, features, and hardware configurations can be daunting. This is why we built AV Player View Controller. So with just a few lines of code, anyone using your app can have an amazing media experience. And all of this leads us lastly to the most important aspect in designing a media experience: making it content forward. This should be the primary goal in your design, and is what we consider the defining aspect of a great media experience. When your app feels intuitive, when all of the integration points and all of the features people expect just work, you bring your content into focus, and everything else fades into the background. There are a few things you should keep in mind, though, specific to designing your content. Make sure you provide all of the appropriate metadata, both in your interface and to the system. Providing this info helps give context to your media and allows the system to provide better experiences in Control Center and the lock screen. This includes things like a title and subtitle, a description, a thumbnail, season and episode information, or start and end dates for live streams. Always keep your media in its original aspect ratio. This allows the system to position your videos on screen in the correct location. Letterboxing your content can lead to experiences like this, or this. Make sure to include support for the latest media standards where possible. For example, HDR and Dolby Atmos. And lastly, Make sure to include audio and subtitle tracks for multiple languages, so your media is accessible to as many people as possible. If there's one thing to take away from this section of the talk, it's that you should keep the focus on your content. We've built the system media players, provided through AV Player View Controller, to make that goal as easy as possible for you as a developer. Now, let's go over some new features we've added to AV Player View Controller, starting with the new visual intelligence features. In this example, we have a video paused on a frame with a code snippet in it. Long pressing the code snippet will select it. You can then copy and paste it directly into Playgrounds to try it out. This works great for macOS as well. Hovering your cursor over the same code will show the I-beam, indicating the text is selectable. You can then use your cursor to highlight it, or use Command-A to select all. We're introducing a new API to go along with this functionality. Available in AV Player View Controller on iOS and AV Player View on macOS. Allows video frame analysis will toggle this feature. This will be enabled for all apps linking against the new SDKs. While allows video frame analysis is set to true, and once the media is paused, AVKit will begin analyzing the current video frame after a set period. Note that we will not analyze frames while scrolling for performance reasons, or for fair play protected content. In general, we think people will expect this functionality in most situations. However, there are some instances where you may want to disable visual analysis, as is appropriate in your application. For example, in performance-critical applications, such as a collection view of videos, or in cases where interaction with the video is not expected, like splash screens. For more info on how to integrate the visual intelligence feature set into your apps, see our related talks on VisionKit. Next, let's take a look at some improvements we made to interstitials. Up until now, interstitials were only supported in AV Player View Controller on tvOS. Well, I'm happy to announce we're bringing the same level of support to iOS as well. Interstitials, either in the stream or defined locally through AV Player interstitial events, will now be marked along the timeline. When the timeline hits a marker, we'll begin playing the interstitial. If your interstitials are already fully defined within your HLS playlist, you'll get this behavior automatically. No adoption required. If not, or if your app requires some more custom behavior, we're introducing some new API as well. AV interstitial time range is being brought over from tvOS to iOS. These will be populated automatically into the AV Player item property interstitial time ranges, which is also being brought over from tvOS. When using an HLS stream, an AV interstitial time range will be synthesized for each interstitial in the stream. When creating interstitial events locally through the AV Foundation API, an AV interstitial time range will be synthesized for each AV Player interstitial event. Unlike on tvOS, however, interstitial time ranges is a read-only property. Interstitials will either need to be defined within the HLS stream or through AV Player interstitial events. For those migrating their support from their tvOS apps, this is in essence equivalent to setting translates player interstitial events to yes. We're also bringing over two delegate methods from tvOS as well. These can be used to know when an interstitial has begun or ended playback. Let's see how we can use these APIs to add a skip button for a pre-roll ad on iOS. First, we'll create an AV Player interstitial event controller for the primary media's player. Next, we'll create an interstitial event. We'll define some restrictions for it. These restrictions prevent seeking within the interstitial and prevent skipping past the interstitial. Then we'll add the interstitial to the event controller. And lastly, we can implement the new will present interstitial delegate callback to bring up an add skip button after a set interval. And once the button is pressed, we'll cancel the interstitial. It's that easy. Note that when adding any custom UI elements to an AV Player View Controller, such as this add skip button, always make sure to add them as subviews of the content overlay view. To learn more about how you can integrate your interstitials right into your HLS playlists, or how you can use the AV Foundation Interstitials API, check out our related talks on exploring HLS dynamic pre-rolls and mid-rolls. Now we'll go over a new feature we've added this year across all of our platforms. native support for playback speed control. Both AV Player View and AV Player View Controller can now optionally show a playback speed menu using some new API we've added. We're making this available on macOS, iOS, and tvOS. Let's take a look at what this looks like. On tvOS, you'll see a new control in the transport bar. Selecting the control will display a list of available playback speeds to choose from. On iOS, this menu will appear in the Transport Control Overflow menu. And similarly, on macOS, the control will appear in the Overflow menu. All apps linking against the new iOS, macOS, and tvOS SDKs will get this functionality automatically, with no additional changes required. However, depending on your use case, some applications may want to modify the list of speeds, programmatically select a speed, or disable the menu entirely. To accommodate these use cases, we've added some new APIs to AV Player View and AV Player View Controller. Let's take a look at these. First, we've added a new class in AVKit, AV Playback Speed. AV Playback Speeds represent user-selectable speed options in a playback UI, and they have three properties. A rate value, defined on initialization, which will be set on the player when the playback speed is selected. A localized name, used to represent the playback speed within the accessibility system. For example, a speed of 2.5 might use a localized name of 2.5 times speed, and a localized numeric name. This value is synthesized from the rate property and will be the string displayed in the playback speed menu. If your app requires a custom playback speed menu external to the player, use this string to represent the speed. Lastly, AV Playback Speed defines a list of system default speeds that should be used whenever possible. You can use AV Playback Speed in conjunction with new API on AV Player View and AV Player View Controller to adapt this feature to fit within your app. The Speeds property allows defining a custom list of playback speeds. By default, this property will be set to the AV Playback Speed System Default Speeds list. Setting this to an empty list will hide the menu. The Selected Speed property will return the speed that's currently active. And lastly, the Select Speed function allows programmatic selection of the current speed. Note that you should only use this function in response to explicit selection of the speed outside of the player UI. Never implicitly override the chosen playback speed. Let's take a look at an example. Here, we're creating an AV Player View controller and presenting it. By default, this will use the system-provided list of playback speeds. You can add a new speed to the menu by creating an AV Playback Speed and appending it to the list of speeds in AV Player View Controller. We can also disable the menu by setting an empty list of speeds. It's as easy as that. Note though, you should always call AV Player Play to begin playback. Never start playback by calling set rate 1, as the selected rate might not be 1. And with that, I'd like to wrap up the session. We saw the new, redesigned iOS system player. We heard how you can design amazing playback experiences of your own. We saw some cool new visual intelligence features and went over our new interstitials and playback speed APIs. I hope you enjoyed the session and look forward to seeing these features in your apps. Enjoy the rest of the conference.